Why 10 and 40 cannot communicate?
Then, sir, update message will be not shared in different protocols. The network will not advertise in different protocols.
No, brother, what I am saying, let's say EIGRP. How EIGRP works? If I am going to run command router EIGRP as number 10 network 12.1.1.0 and 10.1.1.0 on router number 1. Router 1 will discover the neighbor over here. After that, it will advertise all the prefixes which is in topology table, right? Like their length prefix to router number 2. Then router 2 will advertise to router 3. And let's say router 3 has received it in the topology table 10 prefix, and here he have OSPF neighbor. Here he has OSPF neighbor. So R3 should advertise these prefixes to OSPF neighbor also, na? Why it will not advertise? Router 3 have some route in their topology table, routing table. R3 have this network in their routing table, right? In the routing table of R3, prefixes are there, and here they have OSPF neighborship also. So why it is not advertising these prefixes to OSPF? Issue is, guys, what? Routing policy. Remember, na? Routing policy is different, right? EIGRP uses different mechanism for metric calculation. OSPF or RIP or static route ISIS BGP uses different mechanism. Routing policy is same or different? Routing policy is
Different, sir.
different, right? So even if router 3 is going to share EIGRP prefixes to OSPF, OSPF cannot understand it. OSPF don't know how to calculate metric. Similar way, router 4 is advertising 40 submit to router number 3, and router 3 is calculating how metric. OSPF is running over here, so it is going to calculate metric based on their formula, reference bandwidth upon bandwidth of link 100 and upon 100. Maybe metric over here is 1, and here they have another EIGRP neighbor. It will not advertise OSPF prefixes. Even router 3 have this 40 submit in their routing table, but this is non via OSPF. Router 3 has used different formula to calculate metric, and for this neighbor, EIGRP neighbor, it is calculating metric by using different formula, right? Their formula is EIGRP 10 raised to power 7 upon least bandwidth plus total delay upon 10 whole multiplied by 256. Oh, so here routers are calculating metric by using dual algorithm. Here in the OSPF domain, it is using different algorithm, SPF algorithm. OSPF uses SPF. Here we can have any routing protocol, OSPF, BGP, ISIS, EIGRP, RIP, static route, connected. Another question, tell me one thing. See, this network, subnet between router 2 and router 4, 34.1.1.0/24. Will R3 advertise this submit to router 2 through EIGRP? Tell me at least this. Oh. This network is directly connected to R3. Will it advertise to EIGRP neighbor? To the OSPF neighbor, you know it will not advertise, right? Router never carry the network information which is running on their exit interface. So for the OSPF neighbor, this network is running on the link, common link, where both the neighbors are connected. It will not include this network information update. But for EIGRP neighbor, guys, tell me, no, because until and unless you will not enable EIGRP on this interface, it will not advertise this subnet, correct? But here, why I will enable EIGRP? I can't enable, right? Maybe this is different company. We need some redistribution. Some route from this domain should advertise in this domain, and some route from this domain should advertise in this domain, right? Some part of company is doing same work, maybe. That is the requirement, right? We cannot enable EIGRP in the other company's link, right? Generally, this will be one link. So what we can do, we can redistribute we can redistribute connected network. This is connected network over here, and I want to advertise it in EIGRP domain, so I can redistribute it in EIGRP. But while redistribution, what it will ask me, whatever components or parameters are required to calculate the matrix for EIGRP, those informations are required, right? So if you are going to redistribute this subnet, connected subnet, any connected subnet or OSPF or any EIGRP other AS number or RIP, OSPF, BGP, ISS, any protocol into the EIGRP, you have to define K values. What is the K1? Why? Actually, you are telling to router that, bro, when you will advertise this prefix, connected prefix or OSPF prefix or BGP prefix or ISIS prefix in EIGRP, you need K values. I know that. So just use these K values to calculate the matrix. Then router can advertise this prefix. Getting my point, guys? Am I right? Similarly, if you are redistributing anything in OSPF, you have to define what? Bandwidth, because OSPF uses reference bandwidth upon bandwidth formula to calculate matrix. Now, at the same time here, if I have two routers, R2 and R3, let's say two service provider, and both the routers are advertising remote site prefix. Remote site prefix. And here if I want, guys, let's say active and backup scenario, primary and backup scenario, like ISP1, ISP2. ISP1 should be my primary ISP, this should be backup ISP. So while redistributing the prefix, here I can configure list matrix. List matrix means I can increase the bandwidth. And here we can send the default one. Automatically it will select router 2 or ISP1 as a primary path. So we can manipulate the path as well while redistribution. Why redistribution is required? Because by default two different routing domain cannot communicate. Two different routing domain means one routing domain means one AS, autonomous system, and autonomous system means the area or group of devices where routing policy is same. In this case, routing policy is not matching. That's why two different domains are not exchanging the prefix. Right? Here, if you are thinking that, okay, Praful, fine. Here I am running EIGRPS number 10. Here if I will enable EIGRPS number 20, then also redistribution required. Tell me, guys, is redistribution required here? Now see, the matrix calculation is same in both domain. Now tell me, if EIGRP 20 is running here and 10 is running over here, can 10 and 40 communicate? Tell me, come on.
No.
No, sir, because this is in the different domain, different area.
Different AS only.
Different AS means again,
Yes.
different policy. Maybe in AS number 10 you are using K1, K2 and K3 for matrix calculation, and in 20 you are using K1 and K3. Router think that if two different AS are there means two different routing domain. So again you have to perform redistribution. Why redistribution is required? Just to define the value or parameter which are required to calculate matrix in that particular domain. So whenever I will redistribute anything in EIGRP, any routing protocol, any type of prefix, in EIGRP I have to define K values. If I am going to redistribute any prefix into RIP, guys, which value I have to define? You know, RIP uses hop count to calculate the matrix, right? So definitely we have to define hop count while redistributing. Similarly in the OSPF, if I need to redistribute something in OSPF, OSPF calculate best path on the basis of bandwidth. So here we have to define bandwidth. Similarly BGP, how BGP calculate best path? Whatever parameters are there, you have to define that. BGP uses attribute to calculate the best path. Right? Then one more thing, that is fine. Now here I am running EIGRP, yes, number 10, and for an example here we are running OSPF in this domain. And now I am redistributing OSPF into EIGRP. So while redistribution, you will go under router EIGRP as number 10. router EIGRP number 10 in the routing protocol mode. And here we will say redistribute. Then which protocol? OSPF. And guys, on a single router we can have multiple OSPF also. So OSPF process ID. Which OSPF you want to redistribute? OSPF process ID, and after that K1, K3, K2, those values. This is the minimum to minimum requirement of redistribution. After that, there are some advanced options available, like you can use route map, and we'll see many more options are there. Those are advanced things, but this is the basic one. So what will happen now after running this command? My router will look up OSPF process 1 routing table, and what table prefixes are there in OSPF process 1, it will advertise all prefixes in EIGRP domain. And how it will calculate metric? It will calculate metric based on the value which you have defined. Clear? And then it will advertise to their neighbor, router number 2. Router 2 again is going to calculate metric by comparing bandwidth which is coming in update and bandwidth of their link, total delay, whatever formula are there, and then it will advertise to R2 and then R1. So R1 will have this 40 subnet. Clear? 1 minute, please. Yes, if anyone have any question, please ask. Clear, guys? Can we see the implementation first, basic implementation? After that, we'll move to advanced redistribution. Let me access already there. Let me configure the devices very quickly. Start from router 1, interface F0/0. Till then, if anyone have any question, when I'm configuring these devices, you can ask.
सर लैंड साइड में जो कनेक्टेड नेटवर्क होते हैं वो भी हम लोग रीडिस्ट्रीब्यूट कर सकते हैं?
हाँ, क्यों नहीं, ऑफकोर्स। अगर राउटर 3 के ऊपर में कोई कनेक्टेड नेटवर्क है उसको भी कर सकते हैं, ACL से भी कर सकते हैं मैच करके। IP एड्रेस
राउटर 1 पे अगर स्विच कनेक्ट है, वहाँ पे कुछ लैंड नेटवर्क है तो हम लोग कनेक्टेड कर सकते हैं ना?
हाँ,
Redistribution.
कर सकते हैं बिल्कुल। So EIGRP is enabled on both the interface F0/0 and loopback 1. F0/0 and loopback 1 enable. Go to router 2, config T, interface F0/0, no such 12.1.1.2, 255.255.255.0, exit interface F1/0, no such, IP address 23.1.1.2, 255.255.255.0, exit router EIGRPS number 10. I'm running 0.0.0 command, means enable EIGRP on all the interfaces. Now I am expecting EIGRP neighborship here. You can see the log message. So IP EIGRP neighbor. So IP EIGRP neighbor. Done. And once we have neighborship, you can verify the routing table also. So IP route EIGRP. So in EIGRP routing table, you can see the LAN subnet from router 1 is coming here. Go to router 3 and let me configure EIGRP here. Interface F0/0, say no such, and IP address 23.1.1.3, 255.255.255.0, and interface F1/0, IP address 34.1.1.3, 255.255.255.0, no such. Now here router EIGRPS number 10. Here I cannot run 0.0.0 command. First of all, first thing which we need to keep in mind is we cannot run network 0.0.0 command here, because we cannot enable EIGRP on all interfaces. We need to enable EIGRP on the interface where 20.23.1.1.0 network is running. That's it. And this side, guys, between router 3 and 4, which network you want to run? Interface F0/0. Which routing protocol you want to run? Let me configure first a static route, okay? Let me show you the redistribution with a static route. IP address 40.1.1.1.255.255.255.0. Now see on router number 1. On router number 1, so IP route EIGRP. 23 subnet is coming. Only 23 subnet is coming. If I need this 34 subnet, guys, let's say 34 subnet means not this WAN link. I am assuming any LAN network here which is connected on router number 3. How to redistribute that? Right? So I am assuming that this is one LAN for an example over here. Then how we will redistribute that? Go to router number 3 and say first of all in which protocol you want to perform redistribution. In router EIGRP as number 10. Router EIGRP as number 10 and redistribute and put the question mark. You can see you can redistribute into EIGRP as number 10 to BGP protocol. You can redistribute the connected network. You can redistribute EIGRP. You can redistribute ISIS. You can redistribute ODR. You can redistribute OSPF, REAP, static and VRF. So guys, 34 network is connected network, right? So I can say connected over here, connected. And if I will hit enter, will it redistribute the prefix? See, command is accepted. Command is accepted. Redistribute, connected. That's it. And now let me take you to R1 and show IP route. You can see subnet 23.1.1.0 is there, right? Correct? Okay, guys. Now, anyone tell me how it have redistributed? How it got the K values? So IP EIGRP topology. In the topology table, you can see first it have installed in topology table. Question is how it have calculated the FD. So IP route, it will see, okay, you are redistributing connected and 23.1.1.0 is my connected network over here. Connected network. So whatever bandwidth is there on their connected interface, that bandwidth or delay or load or reliability or MTU will be used for metric calculation. Now here I am going to configure one static route, let's say 440 subnet 40.1.1.0 255.255.255.0. Then I am saying in exit interface F1/0 and next hop IP 34.1.1.4. This is how only we configure a static route and router EIGRP 10. Now on router number, sorry guys, extremely sorry, here I have configured it on R1. Go to R3 and say IP route 40.1.1.0 255.255.255.0 exit interface F1/0 and 34.1.1.4 is the next hop and router EIGRP as number 10 because until and unless you will not redistribute it, router 1 will not receive it. So IP route EIGRP only 34 and 23 is coming. And see guys, what is the difference between these two prefixes? Here the symbol is D and here the symbol is DEX. First difference. D means EIGRP and DEX means EIGRP external. Another difference is here you can see the AD value is 90 and here for the external prefixes AD value is 170. So if EIGRP is receiving same prefixes from same prefix with same metric from the inter area and intra area, then which one it will preferred? Which one will be preferred, guys? Inter domain or intra domain prefixes? Inter domain. Even if metric is same, then also it will not install both in routing table, right? because AD value for internal prefixes is lower than the AD value of external prefixes. 90 will be always be for our 170. This is interview question. This is interview question like that. Or EIGRP router is receiving same prefix with same metric from two neighbor. One neighbor is advertising in the same domain, means internal prefixes, and one neighbor is advertising external prefixes. Will router use metric for best path selection? No. Router will never compare the metric. When router compare metric? When AD value tie. Right? Here you can see AD value is different, right? So even it will not compare the metric. They can create the scenario like I have router 1 here. Router 1 is connected to one another router R2 and one another router R3, then R4, then R5. And here I have one X subnet, here I have one X subnet. Then I can say here we are running which protocol? This is, let's say, in OSPF domain. Here X prefix is coming from OSPF domain, and here EIGRP ES number 10 is running, and here also EIGRP ES number 10 is running. Now you tell me, na? You tell me which prefix is best. If router 1 need to send traffic to X network, router 1 will forward traffic to R2 or R3. To whom? Metric to reach in X network via R3 is greater than the metric via R2. Then also it will forward traffic to R3 via R3 only, because AD value here, AD value is going to be 90, here AD value is going to be 170, because this is redistributed prefix, this is external prefix. Right? So now on router number 3 I am going to say redistribute and static route, and then go to router number 1 and check. See, 40 subnet is coming, right? 40 subnet is coming. This is a matrix 3, 3, 2, 8, 0. On router number 3, what is the matrix? So IP, EIGRP, topology table. Here is the matrix. Again it is using the matrix of the interface where this network is installed. Means K values of the interface where this network is, from the interface on which this interface is, this network is reachable. Right? So it is reachable from F1/0. So it will use the K values of F1/0. Right? Even you can set the value, like every time you should use this K values. Router EIGRP ES number 10, and here I can say metric maximum hop. Here you can set okay, that is fine. Maximum hop and weight. Yes. Here toss field I can say 0. We will discuss this in quality of service. Here I am saying 0. And then it is asking for the K1 value. K1 I can say what? 200. Always use K value K200 while redistribution. Means I am telling that K1 should be always 200, K2 should be always again 200, K3 should be always again 200, K4 should be again 200, K5 should be 200, like this. So I have defined, you can see I have already set all the K values. Now I am getting the error message. Neighborship is flapping. Why? Because of K values. This is not the K values configuration, guys. This is what? means it is not using K1 and it is using all the K values, but router 2 is only using K1 and K3. Right? The different command for that. See, again neighborship is up. Matrix wait. This is to change the, this is used to change the K values, like which K value you want to use. Now here router EIGRP is number 10, EIGRP stub router ID log never change. No, there is one command, redistribute. There is one command through which you can set the default K values for redistribution. That when you are redistributing any protocol, any types of route into the EIGRP, it will use that K values, right? I'm not getting the command right now. What is the command? But we can find that command. IP is not there. Let me check one. What are the options here? Address family, auto summary, VFD default information originate. Yes, default matrix is the command. What is the command? Default matrix. Default matrix. Right, so this is going to be default matrix, right? Default, it will use this one. By default, when we are redistributing a static, right, we have redistributed a static dot and connected dot into EIGRP, but we didn't define the K values. So my router used default one only, and here we can change that default one. Now I can say your bandwidth should be this one. Delay should be 100. Reliability, full reliable, 100% reliable, 255. Load, 100% load. Load, let me reduce it to 100. Then MTU, 1500 byte. Now, whenever you will redistribute anything, any prefix, it is going to use these K values. These K values. Now you can check the matrix here. So, IP, EIGRP topology. Now you can see 440 subnet guys matrix is different. Earlier, this was the matrix. Right here. Now for the distributed prefix, it will be using this K value. Now, while redistribution, we don't need to define K values into the EIGRP. Now you don't need to define K values while redistribution. Otherwise, router EIGRP 10 and redistribute a static, and here you have to define the K values matrix. Even if you are redistributing the connected, you have to define the matrix component K values. If you are not going to define the K values, it will use the default one, and default one is this one. Here we have configured it. Is it clear, guys? We are not leaving it on default, right? For the redistributed prefix, it is going to use my defined K values for the matrix calculation. Right? And after that, here we can run any protocol also. Now even ping will not work because route on router number 4 is not there. If I am going to ping from 10.1 to 40.1, so IP route EIGRP, even 40 subnet is coming, you can see, because it is redistribution. Router 3 is redistributing it. This is external prefix coming from different domain. Right? So IP EIGRP topology, in the topology table also you can see. Is there any information about, guys, internal and external prefix here? Can we verify it in the topology table? Not like this. If you want to verify, you have to open it in detail. 40.1.1.0. Again, there is no information. Let me put the subnet mask 255.255.255.0. Now you can see what it's saying. Route type is external. Remember, in route map we had one option to match route, internal route or external route. Now here if I want to filter the external route, simply in the route map I can match it. Everything is connected, guys. See, route type is external. This is external prefix. And if I am going to open 23, here you can see 23.1.1.0, 255.255.255.0. This is route is internal. So that's why here AD value is 90 and here AD value is 170 for external prefixes. State is passive in the topology table, FD. You can verify all the things: minimum bandwidth, total delay, reliability, load, MTU, shear, hop count, and originator router ID. Who is originating this prefix? Router 2. Router 2 is advertising to router number 1, right? So router 2 is using this router ID 23.1.1.2. Right? Now here on router number 3 we can run any protocol as well. Do so run section EIGRP. In the EIGRP you can see we are redistributing two things. Connected route, first of all I am going to remove it. No, it's not required now. Router EIGRP 10 and no redistribute this one. No redistribute static. Right? And now let me enable OSPF protocol here between router 3 and router 4. Interface F1/0, say IP OSPF 1 area 0. Before OSPF, if you want to see the RIP or EIGRP another AS number, then please let me know, guys. RIP is required? Is RIP required? Do you want to redistribute
Yes,
RIP?
sir.
Then let me enable RIP first. Router RIP and 34.1.1.0. Let me enable all the protocol here. 34.1.1. Router RIP version 2 network, no auto summary and network. Which network? 34.1.1.0. Let me enable OSPF also. Interface F1/0 IP OSPF 1 area 0. I have enabled the OSPF as well. If you want to enable BGP router, BGP AS number 100 and neighbor, let's say 34.1.1.4 and remote AS of neighbor is also, for an example, 100. So we have enabled the BGP as well, all the protocol. On router number 4 also, let me enable all protocol here. Interface F0/0 IP OSPF 1 area 0. So first of all I want OSPF neighborship here between router 3 and router 4. Then router RIP version 2, no auto summary and network 34.1.1.0. Now RIP should also extend the database here. And then finally router BGP AS number 100 and neighbor 34.1.1.3 and remote AS of this neighbor is 10. Sorry, 10 100. It was 100. Right? So I am expecting now BGP neighborship. So here you can see the BGP neighborship and so IP OSPF neighbor. You can see we have OSPF neighborship also, right? On router number 3, all the protocols are enabled. So IP route RIP. In the RIP routing protocol, you can see nothing is there, but so IP RIP database. In RIP database, you can see 40 submit should be there. Okay, on router number 4, now let me advertise the prefixes. Router LAN prefix, router BGP 100 and network 40.1.1.0 mask 255.255.255.0. Exit router OSPF 1 and network 40.1.1.0 0.0.255 area 0. Then router RIP version 2 no auto summary and network 40.1.1.0. Now go to R3 and check. So IP RIP database. Wait for some time. You know RIP is slow protocol. Let me show you till then. So IP OSPF database. So in the OSPF database, here is the router LSA of router 4 if you will open it in detail, you can see two links are there, database and router and 40.1.1.1. So you can see this submit is coming here in the OSPF through OSPF, right? 40 through RIP also 40 submit. Why through RIP it is not coming? 34 submit is here. So IP protocol summary, is RIP running? Yes, RIP is running. So IP RIP database 40 submit is there, no problem at all. So run section RIP. I think version is mismatching, 34 and 40 no auto summary fine on router number 3. So run section RIP, router RIP version 2, network 34.1.1.0. oh, 34.0, everything is good. It should exchange the database. So IP RIP database 40 submit is not coming here, don't know. But so IP BGP, in the BGP table also you can see 40 submit is coming. But router will install which one in routing table? So IP route 40.1.1.0. In the routing table, guys, static, because there is a static route. Let me remove the static route now. Config T, no IP route, or we can verify. Do so, run section IP route and say no to this. No to this static route. Done. And now so IP route 40.1.1.0. Now you can see this network is non via which protocol? BGP 100. Non via BGP 100. Distance is 200. Why it is not best via OSPF, guys? So IP OSPF database. Here 40 submit is coming in the router LSA of router 4. But why that is not best? That should be the best. What is the AD value of OSPF?
110.
110.
In the routing table, so IP route OSPF was taking some time. Now you can see this prefix is best via which protocol? RIP. This protocol is best via RIP now. RIP is using which AD value? 120. OSPF is having AD value 110. So here OSPF should be there in routing table. No? So IP route 40.1.1.0. 40.1.1.0 is best via, guys, OSPF. It have installed via RIP also. So IP SAF 40.1.1.0. It should install via OSPF only. OSPF. RIP should be not there. This is error. Right here AD value is okay, guys. Here you can see the slash value is 32. Extremely sorry because of OSPF network type. Maybe now you don't know this. I will tell you about this in the OSPF course. Here just I am going to run one command. IP OSPF network point to point. That's it. Now on router number 3 you can check. Best should be via OSPF. Now you can see best is via which protocol? OSPF. If OSPF bill goes down, then RIP prefix will become best. If RIP bill goes down, then BGP prefix will become best. Right? So let me take you to config mode and say router EIGRP as number 10 and redistribute RIP. That's it, because we have already defined the key values. Let me take you to R1 and let me show you the routing table. So IP route EIGRP. Guys, is 40 submit coming? Not coming. Now can anyone tell me why it is not coming? We have redistributed RIP into EIGRP 10, but still 40 prefix is not coming. Why? Because there is no any prefix in RIP routing table on router number 3. So IP route RIP, is there any prefix? No. There is no any prefix, right? So IP RIP database 40 submit is clear, but it is not best because OSPF is running, right?
Yes.
Okay, so this is how you will redistribute RIP into EIGRP. Now router EIGRPS number 10, I am going to remove RIP. This is even not so important. And let me say redistribute OSPF and then OSPF process ID. OSPF like this you cannot redistribute. You can see error. OSPF process ID, let's say 1. Now go to router number 1. First here check. So IP route OSPF. Is there any prefix available in the OSPF routing table? Yes, 40 is there. So now it will redistribute this into EIGRP. And now here you can see 40 submit is coming. And this is external prefix. AD value is 170. Right? If you will open here in detail 40.1.1.0 in the routing table. So IP route and 40.1.1.0. Right? Here guys, are you able to understand this is internal or external? Yes. In the routing table also we can identify that. Here you can see type is external. In the topology table also we can verify it. So IP, EIGRP topology and 40.1.1.0. Here it will say route type is external. External. But can I identify the prefix is coming from which routing protocol? Is it OSPF? Which routing, from which domain it is coming? The external domain is what? Static, connected, EIGRP, other is BGP, OSPF, ISS. Which protocol is there? So here that information is also there. You can see external protocol is which protocol? Guys, OSPF, right? So on the basis of source protocol also we can perform filtering here. On the basis of source protocol we can match source protocol as well, right? Even I can match this keyword. External protocol is OSPF, right? And the external matrix on router number 3 for 40 submit is 2. So the external matrix you can see is 2. Means you know the meaning. What it's saying that here is one submit 40.1.1.0/24 submit mask coming from 34.1.1.3 coming from 31.1.3 originator. Router is this one, and this is external prefix. Route type is external. This is the matrix. These are the K values, and after that the external protocol is OSPF, and matrix from my router, advertiser router to this destination is 2. Clear? Matrix from originator to destination is 2. These all informations are there. Done. This is OSPF redistribution into EIGRP. But can 10 and 40 subnet communicate? Ping 40.1.1.1 and source 10.1.1.1. Can it ping? No, ping will not work because reverse path. Router 4 don't have route, so IP route OSPF. No. So on router number 3, router OSPF process 1. In OSPF we can redistribute EIGRPS number 10. And here we can use the keyword subnet for classless redistribution. And after that matrix. Matrix over here is cost. Matrix type are also there, but we'll not talk about detailed redistribution of OSPF here. In the OSPF domain we'll see that. Matrix here I can set, let's say I am saying matrix is 10. So OSPF will advertise all the EIGRPS number 10 prefix with matrix 10. On router number 4 you can check now routing table. Now you can see all the prefixes of EIGRP domain is coming. 10.1.1.0 is also coming, and matrix is nothing but the 10. Is it internal prefix or external? This is external prefix. So IP route. So IP route and 10.1.1.0. Yes, type is external. Clear? So now 10 and 40 can communicate. Yes, now communicate. You can see ping is working now. Right? Now if OSPF is down here, interface. First of all, let me redistribute BGP now. Router EIGRPS number 10 and this time I am saying redistribute BGP AS number 100. So IP route EIGRP. So IP EIGRP topology 40.1.1.0 255.255.255.0. Right, still it is coming from OSPF. BGP is not redistributing. Why BGP is not redistributing? Because so IP route BGP 100. In BGP 100 routing table there is no any route. If my OSPF and RIP will goes down, then BGP router will install the BGP prefix. Right, let me say here no router RIP and no router OSPF process 1. Now so IP route BGP. Now you can see BGP sub prefix is installed via BGP, and now on router number 1, if you will check, you can see prefix is not coming. Wait for some time. So IP route EIGRP 40 subnet is not coming. Around router number 4, so IP route BGP. Okay, sorry, on router number 3, so IP route BGP. So IP EIGRP topology. In topology table also it have not installed the 40 subnet. Why? What happened, guys? Do so run. So run section EIGRP. We are redistributing BGP AS number 100. That is correct. Right? Even the default matrix is configured. And in the BGP routing table we have prefix also. Why it is not redistributing then? Right? So IP EIGRP topology, it have not installed it in topology table. Router EIGRP as number 10. Do so run section BGP. Make sure BGP as number 100 is running. Yeah, 100 is only running. Redistribute BGP as number 100. Metric, we have already set the metric value. No need to define. It's look like the issue of BGP redistribution into OSPF. Interface F1/0 and IP OSPF 1 area 0. Router EIGRP 10. Do so run section EIGRP. No. So let me say no redistribute BGP 100, and let me say redistribute OSPF process 1 and interface F1/0 IP OSPF 1 area 0. Here on this router redistribution of BGP is not working properly. No worry, we can ignore it for now. Now you can see again 40 submit is coming. This is simple redistribution. Now let me modify some, guys, here some part of this network. Now for an example, this is my company, this is my company, and here are two different companies. I'm merging two different companies here. One more routers are there for an example. And router number 3 is my border router in this kind of case, right? The border router means the router who is connecting two different types of network, two different AS. When a router is connecting two different AS, that router is known as border router. Let's say here we are running OSPF, and here we are running which protocol, guys? Tell me any protocol here. Let's say RIP to make it easy. Here I am running RIP. Right? Here also 40 subnets are there, same subnet. Router 5 is also going to advertise same subnet 40, and router 4 is also going to advertise same subnet 40. And here I am running, let's say 35 subnet, 35.1.1.0/24. Topology clear to everyone? Is topology clear? Right? Maybe now 500 prefixes are coming from OSPF domain here to router number 3. How many prefixes? 500 prefixes are coming through OSPF here, and let's say 1000 prefixes are coming from RIP. 1000 prefixes are coming from RIP on router number 3. Router 3 have 3 neighbor. One EIGRP neighborship is there between router 2 and router 3. Between router 3 and 4, OSPF neighborship is here, and between router 3 and 5, we have RIP. We have what? RIP. This is, guys, advanced redistribution. Let me first configure the scenario. Let me take you to router 3. Here I need access of router 4 also. Sorry, router 5. Go to router number 3 and say no router OSPF 1, no router RIP, and no router BGP 100. On router number 4 also, I am going to say no router OSPF 1, no router RIP, and no router BGP number 100. Okay. And on router number 5, let me configure the IP. Interface F0/0, no cert, IP address 35.1.1.5, 255.255.255.0. Exit. Interface loopback 1. Or, guys, here we can say, like, here we have multiple subnet 20.1.1.0, 20 not 30, 30.1.1.0/24, 30.1.2.0/24, 30.1.3.0/24, and let's say 30.1.4.0/34. Let's say these are different departments here in this company, right? And here we have 20.1.1.0. Suppose these are different departments in the company. These are the different departments. Okay. Now let me create these loopbacks here. Interface loopback 1, IP address. I'm going to say 30.1.1.1, 255.255.255.0. Interface loopback. What happened? 30.1.1.1, 255.255.255.0. Interface loopback 2, IP address is 30.1.2.0. Interface loopback 3, and IP address is 30.1.3.1. Loopback 4, IP address is 30.1.4.1. And let me enable the RIP version 2. Router RIP version 2, say no auto summary, and network 0.0.0. I have enabled the RIP routing protocol on all the interface. Now go to router 4. Say again interface loopback 1, IP address 20.1.1.1, 255.255.255.0. Interface loopback 2, 20.1.2.1. Interface loopback 3, 20.1.3.1, and 4.1 also is there. Loopback 4, 4.1. 4. Let's say 3.1 here. 3.1. This is 20. Clear? And let me enable OSPF protocol here, router OSPF 1 and network 0.0.0.0.255.255.255.255 and area 0. This command will enable OSPF on all the interfaces here. So IP OSPF interface brief. You can see OSPF is enabled on all the interfaces. Now go to router number 3 and let me configure. See, do so IP EIGRP interface. EIGRP is already enabled on fast Ethernet 0/0. That is fine. Good. Do so IP EIGRP neighbor. So EIGRP neighborship is already there. Now let me form OSPF neighborship with router 4 and RIP database exchange with router number 5. Say router OSPF 1 and network, and simply we can do one thing on interface F1/0. I can say IP OSPF 1 area 0. Then exit. Go to router RIP. Say version 2 here. You can see OSPF neighborship, no auto summary, and network 35.1.1.0. That's it. That's it. Now router 3. So IP route EIGRP. Guys, router 3 is learning 10 prefix through EIGRP. See, 12 subnet is there. This is unwanted prefix. You know this. I can filter it. Simply I can say access list number 10 deny, or guys, in the access list number 10 I am only allowing, see, LAN subnet 10.1.1.0 wildcard mask 0.0.255, or I can advertise company 2 prefix, right, where OSPF is running 20.1.0.0 and wildcard mask 0.0.255.255. It will match 2 bits. Access list number 10, 20, and here we can say 30 also. Only these prefixes are allowed in EIGRP. Here I can apply it on EIGRP distribute list number 10 direction in. That's it. Now you will not have WAN prefixes in topology table or routing table of EIGRP. So IP route EIGRP. Now you can see, wait for some time, resynchronization. Yes, now you can see only 10 subnets are there. Great. So IP route EIGRP. In EIGRP routing table, 10 subnets are there. So IP route OSPF. In OSPF routing table, all the 20 subnets are there. And so IP route RIP. In the RIP database, no prefix. So IP RIP database. Okay. Config T interface F1/1 no cert and IP address 35.1.1.3 255.255.255.0. This was the issue. So IP RIP database. Now wait for some time. So IP RIP database. Great. On router number 3, now let me check the RIP routing table. So IP route RIP. Now you can see in the RIP routing table we have 30 subnet. In the OSPF routing table we have 20 subnet, and in EIGRP routing table we have 10 subnet. Clear, everyone? Now you don't need to manipulate the metric of EIGRP while redistribution with the help of K values. That's done. Now that is not my requirement. While redistribution, we don't need to perform now manipulation with metric. We have set the default metric. It will use that for all other routing protocol redistribution into EIGRP 10. Right? So now you can see in IP EIGRP topology. In topology table, guys, OSPF prefixes are not there. Even RIP prefixes are not there. Now if I am going to say first here router EIGRP 10 and redistribute OSPF. Router EIGRP number 10 and redistribute OSPF process 1. What will happen? It will install all the OSPF prefixes in their topology table. So IP route OSPF. In the OSPF, these are the prefixes. And so IP EIGRP topology. Now you can see in topology table all the 20 prefixes are installed. right? And now it will advertise to their neighbor as well. If it has installed it in their topology table, it will advertise to router 2, router 2 will advertise to router 1. And now here, if I am going to check the routing table of EIGRP, you can see all the 20 prefixes are coming, and these all are external prefixes. AD value is 170 external. Good. Good, guys? Yes. Now here in the routing table, when you open the routing table like so IP route, you can see, guys, here am I able to understand that these prefixes belongs to which department, coming from which company, which type of prefix it is, why it is coming here? Are you able to see anything? No. I am only able to see one thing, that this is EIGRP external prefixes. That's it. This is the only information here in the routing table, that this is external prefix coming from EIGRP domain. If you are going to open it in detail, then you can know the type, route type only. The same information which is already available here, like 20.1.1.0 and 255.255.255.0. Here also it's showing that this prefix is known via EIGRPS number 10. Distance is 170. This is the metric, and prefix type is external. Redistributing into via EIGRPS number 10. That's it. Is there any other information? No. Here are the K values. Not about the network type and those all things. Now, guys, assume that this is which company? Company A. Company A or department A, you can say company B. Or it can be my branch 1, headquarter, and company A can be my data center of a same company also, right? This can be department, it can be different companies. Company C. And here if I want to mark, like in company A, whenever any prefix from company B will enter, what I want, any subnet is coming in company A from company B, they should have one tag to identify. They should have one tag of 100. Tag of 100 means if tag value is 100 with any prefix, that means that prefix belongs to company B. So we are going to maintain one database first of all, right? You are the network engineer of company A, you will have this database. You are going to keep record of these all things. That the prefix which is coming with tag value 100 belongs to company B. Any prefix with tag value 100 belongs to company B. So like this type of redistribution we can note. See this, we cannot identify it. So while redistribution, now we can use what, guys? Tag router EIGRPS number 10 and say no to this redistribution. And again I am saying redistribute OSPF process 1, and this time I am going to add tag. How I will add the tag? See, I don't have any tag option here. How I can add the tag? With route map. Here I can, yeah.
Only OSPF, with OSPF only work this tag, or every?
No, any routing protocol, doesn't matter, na? Here, redistribute, after that you can have any routing protocol here, static, connected, or any dynamic routing protocol. And I can call any route map here, right? Let's say I have one route map with name what? Company B to A prefixes. I have one route map. What is the name of my route map? Company B to A prefixes. And now guys, I will create this route map. In this route map I will add the tag value. Which tag value? Route map company B to A prefix permit sequence number 10 I can say, and I can say set tag value 100. That's it. Now on router number 1 you will have tag 100 with all the prefixes of company B. Means when router 3 will redistribute any OSPF prefix into EIGRP 10, it will add the tag value 100. How we can verify it? Now you can see show IP EIGRP topology table. In the topology table, 20 subnets are there, right? But I want to see the prefix which are coming from company B. So I can say include tag is 100. Now it will show me all the prefixes which are coming from company B, right? So IP route and 20.1.1.0. Here also you can see route tag is 100. And what is the benefit of this tag, guys? Policy. Now you will have requirement, right, to configure apply policy for all the traffic which is going to company B or coming from company B. Here in company A, I have some requirement, right? Right? Maybe I want to configure some quality of service for the prefixes for company B, for the traffic of company B. What I want, when any user is forwarding traffic to 20 subnet from router 1, it should prioritize it. I want to configure, let's say, security, means I want to limit the access. I can do it because guys, we know the prefixes of company B is using tag value 100. So by using that tag value, we can perform route filtering, we can configure the policies, we can limit the access, we can configure anything. First, you can identify the prefixes, right? And here again, you have in the same database, you have note that tag 200 belongs to company C. Tag 200 belongs to company B, right? So on router 1, I can have not one more route map. Route map route map company C2A, company C2A prefixes permit 10, and here I can say set tag 200, right? Now on router now on router number 3, we need to perform redistribution also. Router EIGRPS number 10 and redistribute RIP and call your route map. Which route map? This route map, where you set tag 2. What happened? Redistribute company C2A prefixes. This is the name of, that's it. Now on router number 1, you can identify it. So IP EIGRP topology, and if I am going to say tag is 100, it will show me all the prefixes of. So IP EIGRP topology include tag is 100, it will show me company A prefix, and if I am going to say tag is 200, it will show me 30 subnet. You can see all the 30 subnets. This is what, this is advanced redistribution. Now guys, now let's say in company B there are 2 departments. Sales department, let's say upper 3 prefix belongs to sales department, and this prefix belongs to HR department. Now how you can differentiate these 2 types of prefixes? In company A, you have requirement of configuring any policy for sales only. For sales department of company B, this is my requirement. Now requirement is different. Are you able to understand? Yes guys, please confirm. Now what I am saying, in company B there are 2 departments, and I want to separate the prefixes of these 2 departments. So while redistribution, On router number 3, in the route map, we set what? Tag value. Now I can set the tag value, but before that we can match the prefix, right? If these are the prefixes, then set tag value, let's say 110. And if this is the subnet, then set tag value 120, right? Like you have this database, the tag is 110, belongs to company B sales. And then you have this tag 120 belongs to company B HR. What you can do while redistribution only we can do it. These all things are possible while redistributing the prefixes in EIGRP. See here. So run section EIGRP. Like this also you can verify, or show IP protocol. Show IP protocol. You can use show IP protocol command also. In the routing protocol, you can see EIGRPS number 10 is running, and here is the redistribution information. Where is the redistribution? Guys, is there any information about redistribution here? No. There is no any information about redistribution. Now this is task for you, how to identify the redistribution of EIGRP. How to identify the redistribution of EIGRP. Except this show command. On router number 1, I am here. Sorry, I should check on router 3. No? Show IP protocol. In show IP protocol, is there any information about redistribution here? Tell me, guys. In the this is OSPF. Here is your EIGRP. Here is your EIGRP. Right? Like you can see, you have applied the filtering. This is fine. About the redistribution, yes, there is information. You can see redistributing OSPF process 1 and RIP. You are redistributing OSPF process ID 1 and RIP into EIGRPS number 10. Right? And here is your default redistribution metric. Default redistribution metric. Right? But we are not able to see the redistribution, how we have redistributed, what route map we have used, right? So for that, this command, so run section EIGRP is fine. So run section EIGRP, yes, number 10. This command will show you all the enable command here. So you can see I am redistributing OSPF1, and while redistributing OSPF1, I am using route map. What is the name of my route map? This one, company B2 A prefixes. Let me open this route map. So route map and company B2 A prefixes. You can see this route map. In this route map, you set tag value 100. Now I am going to remove it. Router EIGRPS number 10 and say no redistribute OSPF1 route map this prefix this. Say no to this. Done. And exit. Now your route map is this one. In this route map only we are going to modify. Right? Even this route map is not required. I can say no route map and this one. And then I can say route map name is company B2A prefixes, and then I can mention the department sales, and then permit sequence number 10. And guys, what will be the summary address of upper 3 prefix? Here I can say now match IP address from access list number, let's say 10. I said match IP address from access list number 10, and if the prefix will match, then set tag value 110. Now it will not set tag value 110 to all OSPF prefixes while redistributing into EIGRP. To those prefixes, we will add this tag value which will match in this access list number 10. And now access list number 10 permit 20.1.1.0, 0.0.255, 20.1.2.0 and 3.0, right? I can create one more access list number, let's say 20, and permit, here I can permit 20.1.4.0, while karma 0.0.255. I need one more route map with name HR, route map, company B2A prefixes, HR means HR prefixes, and here I am saying match IP address from access list number 20, and then set tag value what? Set tag value 120. You can also set the matrix, See how many things you can set here, guys. IP means for the next hop, IP next hop. In the PBR, in policy based routing, you will learn these all things. Maximum thing from here, but for now you can set the weight value, matrix type, matrix, network type, right? So I am setting the tag value here 120. Now on router number 1, if I will ask you that show me the prefixes of company B which belongs to sales department, then you are going to run command so IP EIGRP tag is 110. No any prefix is coming, guys. What happened? What happened, guys? No any prefix is coming. Redistribution, right? So IP protocol in EIGRPS number 10, you can see we are only redistributing RIP. Let me now redistribute. Router EIGRP ES number 10 and redistribute OSPF process ID 1 and then call your route map. Which route map? Do so run section route map. Route map, name of my route map is this one. Company B2A HR prefix. I did some mistake. We should create the same route map because we can call here single route map, right? So say no route map. Here we have two route map. We should have same route map now. So let me say no to this route map and no to cells also. Cells also. Okay. Do so access list. Access list. My access list number 10 is matching. Oh, access list 10 is already in use for this submit. Let me create any another access list. IP access list and let's say let me use number 50. Access is 50 permit number standard and then 50, or even I can define the name. So let me define the name, that is better. Let's say sales, right? And here I can say permit 20.1.1.0, 0.0.255, permit 20.1.2.0, permit 20.1.3.0, and one more access list with name, let's say HR, and here I will permit 20.1.4.0, 20.1.4.0. Now let me create one route map. Let's say name is B2A. I'm taking simple name B2A permit sequence number 10, and here I am saying match IP address from access list name, access list name cells. From this, match the prefix and set tag value 110. Then exit. Same route map with higher sequence number 20 and says match IP address from access list name HR, name of your access list HR, and set tag 120. That's it. Now router EIGRP number 10 and redistribute OSPF process 1 and use route map B2A. That's it. And go to router 1 and check now. Now you can see with tag number 110, upper 3 prefixes are coming, right? These prefixes are sales prefix of company B. And if you want to check HR prefix, you can say tag is 120. You can see. Getting my point, guys? So these types of redistributions are available. You can use here for any protocol, not for only OSPF. For RIP also you can do the same task. In the roadmap, we can set the tag value. Now, another option here, router EIGRP number 10, redistribute OSPF 1, and you can see we have, guys, matrix. So we have already covered the matrix. Then we have route map option. And here we have one match option. What is this? See, if I'm going to say match here, what it is saying? Match OSPF type. These are the OSPF prefixes. If I'm going to say external, then it will only redistribute OSPF external prefixes. And this is protocol specific. This will be not for all the protocol, right? These options are available for OSPF only. OSPF internal prefix, external prefix, and NSSA prefix. Right now, maybe you don't know about these prefixes, but in the OSPF, you are going to master it, right? So we can match that also. In the roadmap, we have multiple things to match, and this is all about your advanced redistribution. In the EIGRP, you can see I don't have any other option for the redistribution. Now, please let me know if it is clear.
Yes, sir. Sir, in BGP case, how we will do if company C is running BGP?
Huh?
In BGP case,
Route redistribute BGP. This is the command. Clear? Now, guys, one more thing here. Now I'm going to remove the RIP routing protocol. Let me say no router RIP.
yeah,
Right?
please configure BGP, sir.
BGP we already did, na?
Okay, okay, sure.
Go through recording. Now,
Okay.
let's suppose this is ISP router. This is, guys, ISP, right? So towards ISP, you will have one default route on your router. Sorry, here now I am going to make single loopback 8.8.8 ISP. This is internet. Now BGP is not running, or we can say service provider. Okay, so on router number 3, now I am going to configure one default route towards my service provider. Let me configure the service provider router first. Config T, interface loopback 1 and IP address 8.8.8.8. Let's say 8.8.8 is any public server on the internet, right? And then interface F0/0 no cert and IP address 35.1.1. 35, or let me, okay, 35 is also fine. 35.1.1.2, let's say here 255.255.255.0. That's it. On the ISP router, I have only configured the IP addresses. Now go to router number 3. Even I am going to close the console of router 4. It is not required now. Go to router number 3 and let me configure one default route, because now I cannot ping 8.8.8, and like 8.8.8, million of sites are connected to internet. So we cannot configure the route or any routing protocol here to exchange prefixes. We will configure one default route, IP route 0.0.0. You know this, we have already seen default route in static route. So 0.0.0 exit interface F1/0 and next hop IP address 35.1.1.2. That's it. Now I can ping 8.8.8, ping 8.8.8. Now you can see yes, ping is working. Right now I'm able to access internet because here I have one default route. Gateway of last resort is now set to 35.2. If router 3 is receiving any traffic and destination is unknown, then it will forward to ISP to 35.2. Right, there is one default route towards ISP. Fine. But what about LAN users? Router 1 guys. Can router 1 ping to 8.8.8? No. Here also you have to configure default route. On router number 2 also you have to configure default route. On router number 2, so IP route. So IP route, I don't have default route. You can see gateway of last resort is not set. So if anyone from router number 2 is going to ping 8.8.8, router 2 will discard the traffic. Router 2 will discard the traffic. Similarly, router 1 will also discard the traffic, right? So IP route, because gateway of last resort is not set here also. Right? Default route is not there, right? So if I will ping 8.8.8, ping will fail. Right? So guys, I need to configure default route on all the router inside the company. Now you tell me, if I have 100 number of router on all the router, I'm going to configure default route. But instead of adding manually default route in the routing table of all routers in company A, you have default route here and EIGRP is running here, right? So better to redistribute this default route into EIGRP. If I am going to redistribute this default route in EIGRP, then all the router will have default route, correct? And this particular thing is called default route propagation. What we called it? Default route propagation. Default route propagation, right? So we have multiple options for the redistribution of default route. See, first is router EIGRP is number 10, and you know your default route is a static route. Do so IP route static. Sorry, I am on router number 1. So IP route static. You can see the default route is a static route. So guys, I can redistribute a static route into EIGRP. So if I am going to redistribute a static, automatically my default route will be redistributed, yes or no? Go to router number 1 and check now. So IP route EIGRP. See, default route is coming. Yes, default route is coming. Gateway of last resort is set. Yes, set to router number 2. Now router 1 can forward traffic to 8.8.8. Right? Now if I am going to ping 8.8.8, ping will work. Ping is working, right? Yes. Traffic is going to ISP1, right? I'm not getting the reply message because we have not configured the NAT on router 3. Debug IP ICMP. If you are going to enable the debugging on ISP router and then send ICMP packet, you can see ISP router is generating the reply, guys, from the source 8.8.8 to 12.1, right? Means it is receiving the traffic. ISP router don't have route, that's why ping is not working. If you will configure here one default route, by the way, in the production you will configure NAT on router number 3. See, forget about the NAT configuration, just I am going to enable the NAT so that we can access the internet. Later we will definitely learn the NAT protocol, right? For now, interface F0/0, I'm saying IP NAT. Inside interface F1/1, I'm saying IP NAT. Outside, and I can get one access list number, let's say 80, permit any, and IP NAT inside source match source from this number 10, translated into the IP address which is running on F1/1, and to enable PAT/say overload. Right now from the router number 1, ping 8.8.8, ping should work now. If we have configured the NAT correctly, then ping should work. interface 1/1 IPNet outside, interface 0/0 IPNet inside. Oh, sorry, in the access is number 10, we match the correct incorrect ACL. ACL number was 80. Now go to router 1 and ping. ISP is receiving the traffic still from the 12.1, means router 3 is not performing the translation. What happened? Do so IP access list 80 permit any one match is there. If NAT is not working, I can configure one default route here on the ISP router, IP route 0.0.0 0.0.0 F0/0 35.1.1.3, right? And now ping. Now it is performing the translation. There is some misconfiguration in NAT, I think. This translating into 3.3.3.
सर आपने एग्जिट इंटरफेस F0/0 डाला,
कहाँ पे?
F1/1 आएगा ना?
कहाँ पे? कहाँ पे? ISP राउटर पे?
यस, IP राउट कर देखो ना, एग्जिट इंटरफेस.
हाँ तो एग्जिट इंटरफेस 0/0 ही तो है. Ping is not working because of NAT translation. Router is not performing the translation properly here. But you don't need to focus on NATing here, how NATing is going to work. Simply, we are verifying the default route in EIGRP domain, and on router number 1, we are able to find default route. So IP route EIGRP. My traffic is going to internet. If you are not getting the reply message, that is misconfiguration of NAT, not your EIGRP. This is the first option to advertise default route in the EIGRP. Now router EIGRP is number 10 and say no to this. Redistribution, redistribute static. I'm going to say no, redistribute static. Now again on router number 1, router 1 will remove the default route. Now again you can see gateway of last resort is not set. Now another way to redistribute default route is summarization. Through summarization also we can advertise, or we can run command network 0.0.0.0 0.0.0.0. This command will also redistribute default route into OSPF, right? And redistribute static default information originate command is also there, auth, right? There are few more options available for redistributing the default route, like candidate of default route, network 0.0.0, summarization, and redistribute with a static route, right? Like with the help of summarization, I can say interface F0/0 IP summary address 0.0.0 0.0.0 summary address for EIGRP 10, sorry, EIGRP as number 10, and address is 0.0.0 0.0.0. That's it. Now on router number 1, again we will have one default route. You can see this time this default route is in same domain, right? This is not external prefix this time. So in the same domain also we can redistribute the default route, or in different domain also we can redistribute the default route. But you can see after advertising the summary address from F0/0 of R3, we are not receiving any prefix of company B as well, right? But I can forward the traffic to company B because default route is there towards router 2. Router 2 have route towards router number 3, and router 3 has all these individual prefixes 20. So traffic can go from router 1 to router 2. But guys, what is the issue over here? If I don't have route, I cannot configure the policy. That's why you will not advertise like this. Okay, that's why you will not advertise like this. Now sometimes, for an example, here you have one router, and guys, two service providers are there, let's say. and both the service providers are advertising default route to you, to your internal network. You are running EIGRP here. ISP1 and ISP2. ISP1 and ISP2. Both are advertising default route. And you want that router 1 should always prefer ISP1. So here you can advertise the summary address 0.0.0. Here you can perform redistribute static, or you can run network 0.0.0 command, right? For the path manipulation, again we have multiple options while default route propagation, while advertising default route into the EIGRP, right? We can also configure candidate of default route. What we can do here, instead of advertising like this, say no to this, and once I will say no to this, go to router 1 and check routing table again. Now you can see again all the 20 subnets are coming, but the default route is not coming. So you know the default route propagation with the help of summarization, with the help of redistribute static, right? And after saying redistribute static, you can say default also. Router EIGRPS number 10, redistribute static and put question mark. Again here you can see I can use route map, and metric default is not there. Metric default option is not there. Sometime on some devices you will find the default as well here. Third is we can use network 0.0.0 command. I can run network 0.0.0, but guys I cannot run this command here, otherwise EIGRP will enable on this interface also, so we are not allowed to run this command. So the last option is gateway of candidate of default route. Candidate of default route. In candidate of default route, what will happen? On your router number 3, where you want to redistribute default route, you can create one candidate. Candidate means, let's say here I have created one loopback 1, and on the loopback 1 I have configured IP 192.168.1.1. Now this is my candidate who will carry the default route information, right? So I will advertise it into EIGRP, right? Like, see how on router number 3 I can create one loopback interface, loopback let's say 10, IP address 192.168.1.1 255.255.255.0. Create the loopback and now advertise this network in EIGRP. Router EIGRP is number 10, network 192.168.1.0. Now router 1 have this network 192. Yes, you can see 192 is coming in the same domain, right? And now IP, where this command will work, IP default network 192, default network 192.168.1.1, 1.1. That's it. Now go to router 1 and check show IP route EIGRP. Now it should advertise the default route. Maybe I am missing any command here, but this is also one option. This is called candidate of default route. So we have generally four ways to redistribute default route, and here your all types of redistribution ends in the EIGRP. Similarly, we will have redistribution in OSPF, BGP, or any other protocols. Clear, guys? Now tell me. Now if anyone have any question, please ask. भाई अब रिक्वेस्ट है आप लोगों से, EIGRP जितना हुआ लैम्प हुआ, जो नहीं हुआ उसको छोड़ दीजिए, forget it, right? After the course you can revise the EIGRP. All good? This is, guys, redistribution. Close this lamp. This lamp is not required even. Not. Right. So what we have seen, first of all, what is redistribution? Redistribution is the process of sharing route from one routing protocol into another, like redistributing OSPF route into EIGRP or EIGRP route into BGP, etc. When redistribution is required in large network. It is required in large network when we are connecting multiple parts of the network or multiple parts of the organization, right? Different parts of organization can run different routing protocols, and then their redistribution help you to connect these different domain, so that route from one protocol can be advertised in another protocol. But it is going to reduce the CPU as well. Like you can note, configure so many redistribution, guys, right? Like let's say if 50 companies are there, maybe on one router 50 redistributions are required in one protocol, right? Like 50 in EIGRP, 50 in OSPF, 50 in that. It is going to be, if you have multiple types of route, multiple types of organization, multiple ES of EIGRP, right? And if you are thinking that will perform so many redistribution, it can perform reduce the performance, right? That's why we come up with a protocol which can be run between the ES. Limitation of IGP is redistribution required every time within the routing domain. Within the routing domain, redistribution is required, and redistribution can reduce the performance. And different routing domain. Between the routing domain, IGP protocol can exchange the prefixes, but between the routing domain, it can't. So we need a protocol like EGP. When I will talk about why BGP, one reason is going to be redistribution only. At that time, I will told you some more